Hello everyone, my name is Meha. I am the Captain GSoC contributor of integration for GitOps-based Deployment Tools focused on Flux and ArgoCD. So yes, I am honored to give the final presentation today about this project. I would like to have a brief introduction about myself first. So I am an undergraduate student from Gujarat Technological University pursuing a bachelor's in computer engineering. So I am also a newbie in the Keptn open source community, and I am grateful that Keptn can give me an opportunity to realize the idea in this project. So first understand what Keptn is. So essentially it's quite hard to understand at first sight, but yes, we can say that it's an event driven orchestration engine for cloud native apps. So it uses a declarative approach to automate the delivery and operations so they can be scaled up to a large number of services. So here, as you can see in the picture, when a change is detected, GitOps tool plays a role in notifying the Keptn about that, and Keptn can trigger a deployment after approval or automatically. So initially there might be some configuration of ArgoCD or say Flux somewhere. So the first step would be like ArgoCD or Flux is connected to a Get repo, which contains the deployment manifest Helm chart and syncs with this repo. When there's something new, then Argo or Flux triggers the deployment and notifies Keptn about this, like deployment.triggered or started event. And then the manifest or the Helm charts get applied to the target cluster. And at last, ArgoCD or Flux notifies Keptn that everything is finished, and it makes the PR to update the production. Now, before creating a project, we need to understand what is the Shipyard file, because Shipyard file is the main thing which is used while you are playing with the Keptn. So let's understand it from the documentation. So yes, Shipyard is defined at a level of project, and it means that all services in a project share this same Shipyard definition. Now, Shipyard defines the stages each deployment has to go through until it is released in the final stage, that is production stage. And a shipyard can consist of any number of stages, but at least one. That is like a stage must have at least the name property, and same applies with the number of sequences. It needs to be have at least one. So let's have a look at the Shipyard file of our project. So here you can see it has stages like say test, production, and inside the stage it has sequences. Here I have one named kickoff, and it has various tasks to do. So we can see this thing in our Keptn dashboard. Here you can see I have one sequence running kickoff, and it has various tasks running inside it. And it says that it started and it finished. It gives us various notifications, and yes, if it fails, then it says it gives you some error message. So yes, this is all about Shipyard file. Now let's come to the notification controller, which is the main component in the Keptn Flux integration. So yes, let's understand this. We can get input or source changes from Helm release updates, Terraform, Git repositories, customize, or say all of them at once. And the notification controller is the component of the Flux, essentially which gets the notifications, and then Flux will send the JSON payload which can change anytime. So the controller handles the events coming from the external systems like say GitHub, GitLab, Bitbucket, etc. And it notifies the GitOps toolkit controllers about the source changes. So the controller handles events emitted by the GitOps toolkit controllers and dispatches them to the external systems based on the event severity and the involved objects. So yes, it is all about handling events. They might be inbound or outbound. Now let's understand the two main concepts in the notification controller, that is provider and alert, which we need to use while we are doing such integrations, like especially in the Flux if you are playing with around the Flux. So yes, let's have an overview of these two GitOps toolkit components. So what provider is? The provider is a type of a API which is used to define how events are encoded in the webhook address when they are dispatched. So the provider type can be Slack, MS Teams, Discord, generic, Google Chat, and many such. So when type generic is specified, why I am talking about generic? Because here you can see our project is using the type generic, right? So yes, when type generic is specified, the notification controller will post the incoming event in JSON format to the webhook address. Now this way you can create custom handlers that can store the events in Elasticsearch, CloudWatch, Stackdriver, etc. So here you can see the webhook address, right? So to receive the events as notifications, a provider needs to be set up first. And once you have set up a provider, we need to create a new alert resource in the Flux system to start receiving notifications about the Helm release, right? So let's come over to the alert. So the alert API says that how events are filtered by severity and involved object, and what provider to use for dispatching, right? Here you can see we have given the provider reference. Now to verify that the alert has been acknowledged by the notification controller, we need to execute one command, that is kubectl-n flux system get alerts, and you will see the alert name. Multiple alerts can be used to send the notifications to different channels or say Slack organizations. Now here the one important specification is event severity in the alert. So the event severity can be set to info or error. Now when it is set to info, like in our case we have set it to the info, what it will do, like the controller will alert if a Kubernetes object was created, updated or deleted. And also it sees that health checks are passing. Another important thing is it gives you a dependency if the dependency is delaying the execution or an error occurs. Now when the severity is set to the error, the customized controller will alert on any error encountered during the reconciliation process. Now, this includes customized build and validation errors, apply errors, and health check failures. If you don't specify an event source namespace, the alert namespace will be used. So here you can see how provider and the payload plays a role together when event have an error, and if the status is alright. So yes, we can also trigger a new sequence in the Keptn dashboard. Here we are selecting potato hat, and let's say the status test, kick off, next, and yes. Here you can so yes, sequence is started. And it says that test evaluation get SLI is passing and get promotion is failing. So why it is failing, so that is also given here, like what the fields are missing, what validation error is there. So this is what we have triggered a sequence. Also, we can see the load testing. I have my Grafana dashboard running with the Ortelius. So here I have selected Keptn ingress as an ingress object. So you can see how many requests are being made per seconds. And yes, you can see all at a time. Yes, this is all about the Keptn Flux integration. We can extend up this to the other things like integrating the webhook, like we are working with the Slack webhook thing. So you can have a look at it. Artifact. So yes, there is a future work can be done with the Slack webhook integration. We can add this to our integration so that it sends us the notification in the Slack, and we get to know like what changes are being made, what failure is being there, and yes, we can subscribe to a Keptn event to push the notifications to the Slack. And yes, we can receive the notifications of each and every activity has been made to our Git repo. So yes, we are working on this, and yes, there are many future scopes with this Keptn Flux integration. Thank you.